Welcome to Mastering LLMOps, where we explore practical, operational strategies for running large language models at scale. Over the next slides, I'll walk you through the lifecycle, workflows, security, and governance practices that keep LLMs reliable, compliant, and cost-effective, and explain why a disciplined approach to operations matters for long-term success. This diagram shows an end-to-end LLMOps lifecycle and how stages interlock from data engineering through model development, evaluation, deployment, monitoring, and governance. Skipping steps creates a risk zone that leads to performance drops, compliance gaps, or security holes. So treating the pipeline as modular but sequential helps prevent downstream failures and preserves reliability. Modular workflows break the LLM process into reusable components, like data ingestion, prompt management, fine-tuning, evaluation, and deployment. That separation simplifies troubleshooting, lets different teams work in parallel, and accelerates scaling across models and business units, while keeping each stage focused and easier to maintain. A dedicated CI/CD pipeline for LLMs automates testing and deployment from sandbox development to production release. Automated prompt testing, drift checks, model validation, and performance alignment reduce human error, enable safe rollbacks, and ensure production matches sandbox benchmarks so changes can be deployed quickly and with confidence. Real-time logging and tracking platforms centralize parameters, prompts, metrics, and artifacts into a single dashboard. That reproducibility makes hyperparameter tuning faster and allows distributed teams to compare experiments without spreadsheets, transforming manual tracking into collaborative, automated analysis that improves model performance and auditability. The LLMOps solution landscape highlights orchestrators like ZenML, Valihai, and TrueFoundry, and core capabilities such as large-scale training, GPU allocation strategies, and prompt versioning. On top of that, LLM-specific features like retrieval-augmented generation and token cost tracking help teams optimize accuracy, latency, and operational cost in production. Continuous monitoring uses metrics like perplexity, toxicity, task accuracy, and latency to detect drift early as user language and external data evolve. Coupled with scheduled retraining triggers, human-in-the-loop reviews, and automated output validation, this approach preserves output quality and ensures models remain relevant over time. Governance combines accountability mechanisms such as role-based access control, audit trails, data lineage, and bias checks with documented policies around fairness, privacy, and explainability. Together, these controls enforce accountability, satisfy regulators, and build stakeholder trust, forming the foundation for sustainable, responsible LLM operations. Real-time security relies on 3 layers: continuous monitoring and detection of anomalous inputs or token patterns, CM-style log ingestion and analysis for rapid threat identification, and dynamic response mechanisms that move from passive scanning to active, automated incident containment, and ongoing production vigilance. A security and governance framework balances input and output controls, sanitize inputs, use prompt templates, and semantic rate limiting to block adversarial instructions, while filtering outputs and restricting plugin permissions to reduce the attack surface, all while preserving user experience and functional flexibility where possible. To broaden adoption, lower entry barriers with cloud-native patterns like serverless GPU, auto-scaling inference endpoints, and pay-per-token pricing that reduce cost and complexity. At the same time, enable federated and edge deployments for mobile and IoT use cases with decentralized infrastructure to support low-latency, secure LLMOps at the edge. Looking ahead, industry convergence on benchmarks, compliance frameworks, and interoperability will reward organizations that invest in modular architecture, automated workflows, and governed systems. Early adopters who standardize operations can out-innovate competitors, minimize risk, and reduce technical debt while capturing efficiency and strategic advantage.